All right, now we're going to look at interpreting the shape of a symmetric data display. So customers of a bagel shop complained that some bagels weigh less than the amount on the label, which was 90 grams. The quality control manager generates a third random sample that contains twice as many data points. So something to think about, it's not possible to weigh every single bagel that they bake or make, whatever, and figure out the average. So what they do is they pull a sample. This is how statistics are done. You can't possibly ask every single person a question, so you pull a representative sample and you can infer things about the greater population based on a smaller sample size. In this case, he increased his sample size to 60 to see if that would yield different results or what would happen there. So the greater your sample size, probably the more representative it will be of your population. Okay, so back to the question. A histogram that represents this third larger sample is to the right. Based on the sample, is a change in the process for making bagels warranted? So once the sample size was increased to 60, the histogram we're getting is now symmetric. So when it's symmetric, let's write that down, it is symmetric. We can see that the left side is mirroring the right side. That means that the mean will be equal to or about equal to the median. They're going to be very close in value. So based on the sample is a change in the process for making bagels warranted. Well, the mean and median weights are both 90 grams, and they're advertising that the bagel should weigh 90 grams, and that is the average weight once the bagel size was, or the sample size was increased. So there's no need to make any changes in the process for making bagels based on the symmetric data display. All right, let's take a look at our follow-up question. Suppose the quality control manager adds another 10 bagels to the third sample. If 5 of the bagels are 78 grams each and 5 of the bagels are 106 grams each, would that affect the mean and median weights? Explain. So if we look at the histogram and we add 5 bagels that are 78 grams, those 5 bagels are going to be, down here. We would have another 5. If 5 bagels are 106, that's going to be adding in, 5 bagels to this category. So it does look like we still have a symmetric histogram. However, because we're given specific values, and we know that the mean and median are both 90 grams, 78, so we put in 5 bagels that are 78. How close is 78 to our median of 90? Well, that's 12 units away. So it's 12 less than 90. If we put in 5 more bagels that are 106, how far away is that from 90? Well, that's 16 grams away from 90. So because we're adding in bagels that are higher than our mean and median, than the 78 is a little bit closer, that is going to pull things to the right just a bit. So the question was, how would it affect the mean and the median? So the median would not change. It's still the middle value. You're adding 5 bagels on the left, 5 bagels on the right. So the median does not change. The mean, however, because you're adding in numbers that are I want to say further away, but those heavier bagels are going to pull the mean to the right. The mean will increase just a little bit. It's only, can you even read that? We only added in 5 bagels, but the mean will increase just a little bit on this one.